So hello everyone, this is lecture 20 for the mathematical physics in which we did up to here. Okay, we studied about the active rotation, the passive rotation, and we saw some these orthogonal matrices which has to rotate or in the rotation, and we get the rotational transformation. Today's lecture gonna be a little tricky, so please pay attention. So from here you can see if we find the determinant of these matrices, that will be plus 1. Cos square theta minus this, it will be plus 1, and also the determinant of this is plus 1. So here are some results. If determinant is plus minus 1, then the determinant means that matrix. In that matrix, rotation can be involved or the reflection can also be involved. Okay, this is a new term, that is reflection. Not that much new. You know about the reflection. What is that? Means if it is in 2D, then there is a line and there is one point here, then the opposite of this point on the other side of line is called the reflection of this point, and this line is called the reflection line. Same if it is in the 3D, then there is this plane, and if point is here and opposite point is here, then it is reflection along the plane. Okay, so if determinant of the orthogonal matrix is 1, then we will say that rotation is involved. Okay, but if determinant m came out to be minus 1, then we call it as reflection through a line in the 2D. But in 3D it can be reflection, means reflection is definitely, it will be reflection there, but rotation can also be involved here in 3D case. So for it is 1, then only rotation, but if it is minus 1, then rotation or reflection both can be possible. In 2D only reflection will be there along a line. So you need to remember these results. About rotation I already told you, and about reflection I just told you what is reflection. Now you will understand more by seeing these examples. What transformation correspond to each of the following matrices? So we need to find that what kind of transformation this matrix will lead. So it is 1 upon 2 minus 1 upon 2, root 3 upon 2 minus root 3 upon 2 minus 1 upon 2. So how will you check? First, take the transpose of this matrix and multiply it with itself. If you get the identity matrix, then we call it as orthogonal matrix, and determinant of this matrix, then we find the determinant of this matrix. Okay, so what is the determinant of this matrix is plus 1. So we call it as that rotation is involved in this transformation with this matrix. And if there is active transformation, means active rotation, then how can you find the angle that at what angle the rotation will be take place of any vector when we operate this matrix with that vector? So for that you have to see this active matrix, active transformation matrix. So it was this matrix, so you will compare this with this. So from here cos theta equal to minus 1 upon 2, and sin theta will be minus sin theta equal to root 3 upon 2, and sin theta will came out minus root 3 upon 2. So it will be given that active rotation, then you will get the rotation of that vector. If it is given that passive rotation, then you will compare with this matrix and find the theta, and for that the plane will be moved or rotated. Now cos theta equal to minus 1 by 2, then you know how it is possible that cos pi plus theta will give you minus cos theta. So at cos 60 it is 1 upon 2, so we'll write it 180 plus 60, it will be minus 1 upon 2. So what is the value of theta is? Theta is 240. This also satisfies this also. So we get theta equal to 240, and theta is what? That anti-clockwise direction. If theta is positive, it will be in anti-clockwise direction. I already told you. So if 240 in anti-clockwise, then it is like this 240. Then 120 will be in the clockwise direction. Okay. So just remember this. Now we can take the example. Let's see, this is in xy plane, it is the x-axis, and if we operate this on this, we will get this. Means this vector, this x-axis vector I cap is rotated to this axis. Now I cap is rotated to this. So if you find the angle between these two vectors, that is a dot b equal to ab cos theta, by that formula you will get the same theta, that is 240. So that's how you can verify. Now let's take one more example. We have this matrix B, and what is its determinant? That is -1. Now I told you, if determinant came out to be -1 and it is an orthogonal matrix, then reflection will be involved in 2D, not rotation. So if sorry so if reflection is involved, then there will be a reflection line. How can you find that reflection line? For that, this condition should be satisfied. Means if any vector is there and if you operate this matrix on that, the sign will be changed, because line is here, and if vector is here, then it will give you this vector, so the sign will be changed. So that's how we put this condition, br minus r. And when this we will see it later. So this condition should be satisfied for the reflection. So let's say this xy vector will give you minus xy after operating this matrix, because reflection involved. Now from here you can see x equal to minus x only when x equal to 0, and y should be this. So what is the r? R is this 0 y, and after normalizing you will get 0 1. Now this is r, and this is remaining same. Now this is perpendicular to the reflection line. This r vector is perpendicular to the reflection line, you know that. Now it is perpendicular to rotation line. So if we find the r vector, means r we have. Now if you find the perpendicular, which is means the vector which is perpendicular to r, so that will be itself the reflection line. So if now this is the perpendicular axis to the reflection line, now it is our y axis. So simply we can say that if the y is the reflection, means on the y axis reflection is taken place, then that definitely the x axis will be reflection line. So if it is j cap, then reflection line will be x axis. Hope you get this point. Now let's take one more example. And just for your clarity, if there is this reflection line at any point lining on that line, then it will not change its sign. Okay, so we can directly use not just applying this br equal to minus r. If we apply br equal to r, then we get r itself a reflection line. Okay, we'll get same result in both cases. So if matrix is given like this, then determinant of C is -1, so we'll say that reflection is involved. Now if we put CR equal to minus R, then R will be perpendicular to reflection line. But let's try it with the second one solution, that is CR equal to R, means now R is itself the reflection line, because there is no transformation in the point on the reflection line, it will not change its sign. That's why we put this condition. So let's solve this and just multiply it, then compare. We'll get this type of thing. This equal to this equal to this. So after solving this, we will get r1 equal to x minus root 3x. Okay, so we'll get this as a reflection line. Now after normalizing, we will get this 1 by 2 1 minus root 3. So this is our reflection line. Okay, now you can find the perpendicular line also by just, you know how to find the perpendicular to a vector. So that will be this. Okay, so this is the reflection line, the r1. So you can find it like this. Now you understand the reflection and rotation in the 2D. So we'll move forward to the rotation and reflection in the 3D. So in 3D, if determinant came out to be -1, then reflection is definitely possible, but rotation can also be involved if determinant is -1. Just remember this. In 2D, there was only reflection if it is -1, but in 3D, rotation can also be involved. And if determinant is 1, then rotation will be involved only. Okay. Now, you will see this determinant of this matrix is +1. Then we will say that only rotation is involved here, along the z axis, and this will give you the theta angle about what angle it is rotated. Okay, in this case ar equal to r, you will put when determinant equal to 1, then you will put just this condition, and r is nothing but rotational axis. Okay, if ar equal to r, then r will be the rotational axis, because r is not changing with the rotation, because it is itself the rotation axis. Just remember this condition for determinant equal to 1, and this denotes the rotation along the z axis by theta angle. Now if determinant came out to be -1, then reflection and rotation both can be involved. So the rotation is about the z axis, we can see this by angle theta, but the reflection is also involved. So here it is along the z axis rotation. Then how can you verify this? Just multiply with z axis here 0 0 1, you will again get 0 0 1. So that's why we can verify that r equal to 0 0 1, that is the rotational axis. But here we will say that reflection involved and rotation involved. So what happen if you give here 0 0 1, then you will get 0 0 minus 1, means reflection is also involved and rotation is along z axis by angle theta. So that's how you can verify that when determinant is -1, then reflection and rotation both are involved. Okay, so here the condition will be ar equal to -r for this. Let's see some examples, it will be better understood then. If matrix M is given like this, then first find the transpose and multiply itself. If we get the identity matrix, it is orthogonal matrix. And determinant, we will find the determinant, that is 1. So what it shows that rotation is involved, only rotation is involved. Okay, now we need to find the rotation axis definitely. So how can you find? mr equal to r, this will give you rotational axis r. So just put the value xyz, here we came this. Now y equal to y, z equal to x equal to minus z, then z and x should be 0 0 and y. After normalizing we will get this. So this is the rotation axis, and this is nothing but j cap. So our rotation is taking place along the j cap. That's how you can find the rotation axis. Now you can verify some things here. You can find the angle, means let's operate this matrix on the I cap. After operating with the I cap, we will get the minus k cap. Then see, if we put the coordinates like this x, y, z, then if we operating with the I cap, then we are getting minus k cap, means it is rotating like this in the 90-degree anti-clockwise. 90-degree anti-clockwise. Okay, so we find the angle. Now if we operate on the k 0 0 1, then it will rotate to this side, so it will came out to be I cap. So try to put 0 0 1 here, you will get the I cap, and rotation is along the j cap, that's why we put it here, and rotation is taking place like this. And after using this result, we find that theta is 90-degree. So hope that with this example it is clear to you. Now let's take one more example. If matrix is given like this, so and determinant came out to be 1, then only rotation is involved. So we need to find the rotation axis. Applying this condition, we will find the rotation axis came out to be this, and this is the rotation axis. Now let's see some things, that with the help of this rotation axis you can't just find the angle, because it was easy here, because it was just single axis and we just operated it. But now this rotation axis is not singular, means it is involving multi components. Now you can't find the direct angle, so you need to remember some results here. Just try to find the m square, means the determinant, means the multiplication of single matrix with the square. If it came out to be identity matrix, try to solve this. If it came out to be m square equal to I, then we will say that this m square will have 360-degree rotation. Okay, and if it is 360 rotation, then M will have 180 degree rotation. Means just remember these results, they will be very helpful in the exam. And if M cube came out to be I, then M cube has 360 degree rotation and M has 120 degree rotation. So you need to remember these results. You can use them in the exam by just multiplying, and you can find the angle, because there is no direct way to find the angle, okay, in the 3D cases. Now let's take one more example. Here is the matrix, and what will be the determinant of this? It will be 0, -1, it will be -1. Determinant of this matrix is -1, so we will say that reflection is involved and rotation can also be involved. So if this is the case, then we will apply this condition, mr equal to -r, because reflection is definitely there. And after solving this condition, we'll get r equal to this, and this is the rotation axis. This is the rotation axis, and perpendicular to this vector, we will get the reflection plane. So question can be asked that find the reflection plane in the 3D cases. So how can you find? So this is the plane we need to find, and this is the vector we are getting, which is perpendicular axis. Okay, so how can you find this equation of this plane? So let's say we imagine a vector r1 in the plane of the reflection. Okay, and this is x cap plus y cap, or it can be I cap j cap, lies on the reflection plane. Now you can see that both are at the 90 degree to each other, so dot product of these two vectors will be 0. So we just substitute this, x upon root 2 y upon root 2 equal to 0, and root 2 will came out and equal to 0, so x plus y equal to 0. This is the equation of this plane. Okay, so that's how you can solve the equations and the questions. There is one more lecture on the matrices in mathematical physics. After that we will start the differential equations, all the types of differential equations. That will be very interesting. So let's end today's lecture here. Thank you everyone.